So the aim of the experiment here is to establish a relationship between tension in the wire and the length of the wire, resonating length. So this is the sonometer apparatus. So in this experiment, what we are doing, we are establishing the relationship between the length, resonating length, and tension in the wire. The tension in the wire is provided by the weight there, and this electromagnet will provide the external frequency, which is about 100 Hertz. So you will learn why it is 100 Hertz in the next year, second year. So the principle which it is based on is resonance. So what is resonance? When two frequencies match, resonance will happen. Here we are trying to match the natural frequency of the sonometer wire with the external frequency of the electromagnet. So basically, when natural frequency of the sonometer matches with the external frequency, the amplitude of vibration would be maximum, which is called as resonance. So nature of graph or formula, instead of formula we have nature of graph here. So basically you have to plot nature of graph between length and tension after you record the observations. So here you have to draw the diagram also, and this is the observation pattern. So here the frequency, as you can see, is constant, which is at 100 Hertz. We are not changing that. We are changing the tension by each time we have to take out one of the slotted weights. So each slotted weight is 0.5 kg. So we have to, for every observations, we have to take out one of the slotted weights. Now there are 5 slotted weights. So the tension would be 5 into 9.8, because 9.8 is the acceleration due to gravity. So this comes out to be 24.5 newtons. So now I have to measure for 24.5 newtons of tension in the wire, what is the resonating length. So basically just put it on here. This is the step down transformer, and you have to make sure that the wire is not in contact with the electromagnet, but it should be aligned. So you can see from here. So the wire and the electromagnet are exactly one below the other. Then what you have to do, this knife edge you have to keep it there only. You can move it, but it's better if you keep it at some well defined value. So here I have kept it 8 centimeter. Then I'll move this one. I have to move it slowly. Whenever resonance occurs, you can hear a noise, or you can also see the vibration of the wire. So I hope you listen to the noise. That is the vibration. The vibrations is, these are the vibrations at resonance. So the vibrations are maximum. That's why you heard a noise. So now let me record the length, resonating length. This is at 73.2 and that's at 8. So it's approximately 73 minus 8. So around 65 centimeter is what I'll get as the resonating length. Now for the next reading, what you have to do, basically take out one slotted weight. So now I have taken out one slotted weight. So now the tension in the wire has decreased by 5 newtons, not 5 newtons, it's around 4.9 newtons. So it comes out to be around 19.6 newtons. Why 4 into 9.8 you have to do, that's put 19.6 newtons. So now I'll again move the knife edge, one of the knife edge again, until resonance happens. Okay, you can see that resonance happened at this length. So I'll just note on that it's 67.1 centimeter to, this is anyway at 8. So it's around 59 centimeter for 19.6. So 65 centimeter at 24.5 newtons and 59 centimeter at 19.6 newtons. So these are the final readings. I have taken 5 readings because I want to plot the graph. So whenever you want to plot the graph, there should be at least 5 readings. So when you plot length, tension versus length, this is the curve. So basically don't forget to write the scale also. So basically scale is, for the y-axis, 1 centimeter would be equal to 5 newtons, and in the x-axis 1 centimeter it would be equal to 4.9 centimeter. So basically I plotted whatever the readings I got. So 4.9, 4.9.8, 14.7, 19.6 and 24.5. So when I plot, I'll get a curve like this. This is not a straight line, basically it will go like this. So it has a curve.